How do you translate user needs into technical specifications? Imagine you're building a new electrical system, but you don't know exactly what the user wants. How do you turn their vague ideas into clear, workable plans? That's what translating user needs into technical specifications is all about. It starts with talking to everyone involved: clients, end users, project managers, and electrical engineers. You ask questions, listen carefully, and gather detailed information about what they need the system to do. This might include how much power they want, safety features, or environmental conditions like high humidity or extreme temperatures. Next, you analyze what you've collected. Sometimes user needs are broad or unclear, so you break them down into specific points. For example, if a user says they want a reliable power supply, you clarify that it should handle a certain voltage level, operate continuously for 24 hours, and tolerate power surges. You prioritize these needs based on what's most important and feasible within your project constraints. Then, you turn these clarified needs into formal requirements. These are precise statements that can be tested and verified later. For example, a functional requirement might specify that the system must maintain voltage within a 5% margin. Performance requirements could set limits on response times or energy efficiency. Environmental requirements specify temperature ranges from 0 to 40 degrees Celsius, and safety requirements ensure compliance with electrical codes and standards. Once you have these requirements, you write them down clearly and unambiguously. Each one should be easy to understand and test. This documentation acts as a roadmap for the entire project, guiding design and development. You then review these requirements with stakeholders to make sure they match what users need and are realistic given your budget and schedule. After that, you allocate these requirements to specific parts of the system. For example, the power supply must meet certain voltage and current ratings, while control circuits need to process signals within a certain time frame. This step ensures every component contributes to fulfilling the overall user needs. Throughout the project, you keep track of how requirements relate to user needs. If changes happen, you update your specifications accordingly. For example, if a client requests higher efficiency, you revise the technical specs to include more energy-efficient components. In practical terms, if you're designing a power distribution system, translating user needs into specifications means defining voltage regulation levels, fault tolerance, and component ratings based on what the user wants, like minimal downtime and maximum safety. For embedded control systems, it involves setting signal timing, processing speeds, and hardware interfaces to match user interface requirements. By following this step-by-step process, electrical engineers can turn vague user needs into clear, actionable technical specifications. This ensures the final system works as intended, meets safety standards, and satisfies the user. It's a key part of project management and design that keeps everything on track from start to finish.